Welcome to the Ordeal of Balls. The survival rate is a mere 10%. I'm still irked that they changed the name to the Ordeal of Spheres in the Funimation dub. Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games. Let's do some more 3D in GameMaker. So last time, we went over how to calculate the surface normals, flat surface normals for triangles for 3D models in GameMaker. And today we're going to be taking that a step further and we're going to be calculating smooth normals for 3D models in GameMaker. So flat shading is okay for certain types of 3D models. For certain art styles, particularly low poly art styles, flat shading is certainly not a bad thing. Maybe for things like rocks that you want to have a more faceted look to, flat shading is generally the desired way of lighting a 3D object. But there's also smooth shading. Smooth shading is rather good when it comes to making an object look a lot more smooth and a lot less like a golf ball than it otherwise would. And that's what we're going to be talking about today. So this is going to involve basically taking what we did in the last video, and instead of directly setting the normals for each triangle, I guess I'll look in the big code window. Instead of directly setting the normals for each vertex based on the normals of that triangle, we're instead going to be, shall we say, keeping track of the normals for each triangle in the model, and then at the end combining them. So as you saw, I have I've loaded a couple more objects into this 3D world. Two of these are just for demonstration. This is a smooth shaded sphere, which is what it's going to look like by the time we're finished. This is a flatly shaded sphere, which has the surface normals for each triangle, essentially just like all pointing in the same direction as each other. And this is a sphere which we're going to be working with, which has not got any surface normal information set on it at all. As at the beginning of the last video with the Going Merry, when I removed all of the surface normals from it and made it very unshaded. That's what this is. We're going to be working on this one. So if you want the files for this, I've provided them in this project, which you can find linked in the video description in both GameMaker model format, which is what I'm using, and also in the more ubiquitous wavefront object format. If you would prefer the OBJ files, you can use those, although, as with the last video, I do not have OBJ loading code included in this project at the current moment, so you're going to be on your own for that. So, let me do something rather similar to what I did to start off the last video, and that is that in the step event, if you were to hit the spacebar, I'm going to just calculate flat normals for the sphere. The way that we did for the Going Merry. This is going to instantly make the sphere that we have over here look like this. As you can see, that's what happened. We've got flat shading on the sphere, but we would like this to look less like a golf ball and more like an actual geometrically perfect sphere. And to do that, we're going to implement smooth shading. So let me, in fact, Control-D duplicate the calculate normals script, and I'm going to call this calculate smooth normals, and I can use that function when you hit the spacebar instead. Let us maximize this code window. I'm going to update the name of that function. The setup for this is going to look an awful lot like the setup for the calculate flat normals code. I'm going to be keeping a large part of this, so therefore, and honestly, I feel like this should go without saying. If you did not watch the previous video on flat normals, you probably want to do that before continuing with this one. All the same disclaimers about stuff that you'll already want to know beforehand from the last video still apply here. Now, let's see. I'm going to get rid of all of this stuff down here where we poke the result of this calculation back into the buffer. I am going to create, up here at the top, I'm going to create a DS map. I'm going to call it var normal underscore cache is going to be equal to ds map create. You can perfectly well just use a struct for this. You could, instead of saying ds map create, you could use an empty struct, and you could use the struct accessor rather than ds map accessor. I'm just going to be using a ds map because I think it's a little bit more universally understood at this point, since structs are still fairly new to GameMaker. And then, of course, at the end, when we're done, we want to delete that so that we don't have a memory leak. ds map destroy. Oh, right. Need to pass the actual ds map parameter to that so that we actually know what to destroy. Next, let's see, I'm going to need to make one small addition to this vector class. I'm going to add an add method to this vector class in addition to subtract, cross product, magnitude, and normalize. This is just a fairly straightforward vector operation. I'm just going to make this a function that returns a new vector, which is the sum of ourselves and the input vector. We understand that. And as for the normal cache, so there's a few ways that you could end up with this result. Let me expand that. Let me collapse rather the output window so that I have a little bit more space in the code editor. I'm going to create a couple new temporary variables. I'm going to call this var. Let's call it v1 underscore key is going to be equal to the string of x1 plus comma string of y1 plus comma string of z1. This is going to look a lot like some of the other x1, y1, z1, v1, v2, v3, whatever pieces of code. This is just going to create a unique identifier for each of the vertices in this model. And I guess now that I think about it, if you want to, you could make this a method of the vector class as well. You could add yourself a new method and, I don't know, either override the toString method, or you could just call it like static get keys function and have it return basically that, but that's up to you. So again, this is going to be a v1 key, v2, 3, v3 key. This is going to be a unique identifier in the form of a string for each one of these vertices. If you have multiple vertices that are in the exact same position in 3D space, they're going to have the same identifier. They're going to have the same key, as I'm calling them. And this is going to be the key that goes into this DS map or into the struct if that's what you decided to make it. And that is going to allow us to keep track of the normals of each vertex as we iterate over the vertex buffer and calculate its normals. And then at the end, we're going to combine all of those values, and that is going to be our final smooth normal. So to do that, we can say if DS map exists in the normal cache, and the key is going to be literally v1 underscore key, else we can do something else. So if something already exists in the normal cache with this key, we can say normal cache DS map accessor v1 underscore key. This is going to be a vector. You know what? I'll start off with what happens if this key is not in the normal cache already. So if the key is not in the normal cache, and I guess I'll just put that in the put a not in front of there, and we'll do this first. Then we can simply set normal cache question mark for the DS map accessor v1 underscore key. We can set this equal to norm. So each of the keys in this DS map are going to point to a vector 3, which represents a normal. And otherwise, if v1 underscore key already does exist in the normal cache, then we can simply say normal cache question mark v1 underscore key dot add the normal. So if this key does not already exist in the map, we're going to set it to that. If it does already exist in the map, we're going to add the normal that we calculated here to it. And we can do this again for the other 3 vertices in this triangle. So we can just v2 key and v3 key. It sounds funny when I say it out loud. And that's actually going to be it for this part of the for loop. So now we can do this all over again. We can create ourselves another for loop, and it's going to look a lot like the for loop that we already had. Some small differences. We're going to be iterating over each vertex instead of each triangle. So instead of doing I plus equals 36 times 3 at the end, we're going to be just doing I plus equals 36. Let's see. We're going to be grabbing the position of each vertex at the beginning of each iteration of this loop, much like we did before. I'm just going to call this x, x, y, y, and z, z, because again, we're just going to be dealing with each vertex instead of each triangle, and each vertex doesn't have three x's, 3 y's, and 3 z's. Next, we are going to be taking the key of the vertex's position. So that's just going to be the string of x, 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 y, y, and z, z, and instead of calling it v1 key, I can call it something like vertex key, because again, there's only one of them. This is a key that's guaranteed to exist in the normal cache, so you don't have to worry about what's going to happen if you try and look up a key that doesn't exist in the map, in the DS map or anything like that. So we can say var norm is going to equal normal cache, question mark array accessor, whatever, vertex key. Again, this already exists. You don't have to worry about this being an undefined value or anything like that. So what this means is that the value of this that you look up in the normal cache with this key is going to contain, if I were to open up the sphere in a 3D model editing program, if this is the vertex that we're looking at, this highlighted one, this blue one, the value in the normal cache with this key, with this vertex's key, is going to be the sum of the normals of, let's see if I can select this triangle, this triangle, this triangle, this, and this, all added together. And after all, when you smooth the normal across multiple vertices, you are taking the average of the triangle normals of each of those vertices, combining them together, and that's what this is here. So this this value will be a vector, but it won't necessarily have a magnitude of 1. So for good measure, we can do dot normalize on this. And now this is going to be a regular normal vector, a normal vector, if you will, which has a unit length of 1, which is generally what you want to have when you're dealing with normals in surfaces in 3D space. And now this has put us to the same place that we were at this point in the last video, and all we have to do now is stuff the values of this normal back into the vertex buffer, and we can be on our merry way. Get it? Because the pirate ship is named Mary? Never mind. So this should be all we have to do. Again, as in the last video, things are either going to be spectacularly right on the first try, or they're going to be spectacularly wrong. If I hit the spacebar, they look spectacularly wrong. So I'm batting 500 here, which honestly isn't bad as far as getting code to work on the first try goes. Anyway, if we look a little bit closer at this, what's going on? Oh wait, you know what? Okay, wow. I was going over this line by line, character by character to see what I'd screwed up, and well, add returns a value. It doesn't modify the original, so that means I'm just gonna have to reassign each of these values in the normal cache before I proceed, because otherwise basically nothing was happening. Because the original value, the first value is going in, and then it was unchanging because the add method in the vector class returns a new value rather than modifying the existing one. Okay, so that goof up aside, let's see if I can at least get this right on the second try. There we go. So we now have smooth shading on this ball. This one over here looks a lot like this one over here. That one actually has like a little divot in the bottom. I'm not sure if there's something wrong in the 3D model or if there's like a mathematical piece of weirdness. I can't see if it's in that one or not. I don't think it is. There might just be something wrong with that 3D model because that's that one was sitting around on my computer for a while before I loaded it into the game. Anyway, that is smooth normals. You can do this to make surfaces look like they have a lot more geometric detail in them than they actually do. This is something, again, as with flat normals, this is something that most 3D modeling tools that aren't like from the Stone Age will already have built in. You can use Blender to automatically smooth normals on an object. You can use, I'm sure, pretty much all of the other ones. I mean, even Model Creator for GameMaker will do it if you ask it to. One more thing of note: if, for example, you have, and I'm just gonna like draw myself a flat plane here. If you have something that looks like this, if you have a model that looks like this, and let's say it's a double-sided plane, and you try to smooth the normals on this, you're going to find that the value in the normal cache for each of these vertices is going to be a 0 vector, and that's going to cause bad things to happen when you try to normalize it and set it to the actual value. Even though none of the actual triangle normals in the shape are going to be a 0 vector because we don't have any triangles that have 0 surface area, they will be they will be equal and opposite, and they will all cancel each other out, and you will end up with a 0 vector. And if you try to use that, I guess I'll leave that open, or I won't, because I click close instead of cancel. Anyway, you are going to find that this is going to lead to issues. You may wish to, before you do something like all of this, you may wish to check if this magnitude is greater than 0 first. Else, I don't know, maybe you'll either just like put in some default value like 0, 0, 1 or something, or however you plan on accounting for that. You may also wish, and now that I think about it, I believe if I try to smooth the normals on the going merry, I believe that will also produce, since some of these triangles are also double-faced quads, this will also cause some things to go awry. Let's see. If I were to walk up to here, and if I were to hit the spacebar, okay, so it hasn't like broken, although we do have indeed some things that don't really look good because we have some normals being smooth that perhaps shouldn't be. For example, this hard 90-degree angle on this on the railing over here. We can see that all the vertices are getting smoothed when perhaps they shouldn't be, and it is quite common. This was the other thing that I was going to mention. It is quite common to, instead of smoothing every triangle in a model, to only smooth triangles that are of a certain that are within a gradient, that are within a certain tolerance from each other. So only triangles that are pointing relatively in the same direction. If I had something like this sphere, you would probably expect all vertices in this 3D object to be smoothed. But if I had something more like a cube, let's just make ourselves an arbitrary cube, you would probably not expect all of the vertices in this cube to be smooth, despite the fact that all of these vertices are in fact touching each other. All of these vertices are in fact like snapped to other vertices. If you want to only smooth the vertices on faces that are roughly pointing in the same direction, you have a few options. You could either reformat this for loop to look a lot like the previous one and iterate over each triangle with x1, y1, z1, etc. And you could recalculate the normals for each triangles there. And you could compare that face normal to each of the normals in the vertex cache. That's going to be a little bit, 1, inefficient, and 2, a lot of typing, so I don't think I'll be doing that. Instead, I'm going to actually calculate the flat normals first. So if I go back to script_calculate flat normals and take the buffer pokes, put the normals back into the vertex buffer, the flat normals, and now in this second for loop, I can read out nx, ny, nz. From I plus 12, I plus 16, I plus 20. And first, let's turn nx, ny, and z into a regular normal vector. I can call this var existing underscore normal is going to equal new vector 3, composed of nx, ny, and z. And then I can take the value in the normal cache and normalize that. And then I can take the normal that's in the normal cache, make sure it has a unit length of 1, of course. And then I can compare these two vectors using the dot product. So GameMaker has, of course, built-in dot product 3D, also just a regular 2D dot product. We in our vector library that I borrowed, I apparently did not carry over the dot product. Okay. Let me grab that real quick. That's a useful one to have. Let's see, the dot product is this one. This is just going to be a somewhat shorter wrapper for the longer dot product 3D function call. Don't worry about it. If existing underscore normal dot the new normal. If this is let's see, if this is less than a certain threshold, then we can insert the values of the new normal. Otherwise, we just won't do anything. We'll ignore it, and the the surfaces will just have the normals that they started with. What the threshold value is going to be, if you want, for example, to only smooth normals that are within a 60-degree angle of each other, remember how the dot product works. If two normalized vectors are pointing in the same direction as each other, the dot product is going to be 1. If two normalized vectors are pointing at 90 degrees to each other, so if they're orthogonal to each other or perpendicular, their dot product is going to be 0. And if two normalized vectors are pointing in opposite directions, then their dot product is going to be -1. So we can say that if we want to only smooth normals of triangles that are within, say, 30 degrees of each other, we can set the threshold equal to, instead of just merely 30 degrees, remember this is going to be, the dot product is going to return a value between 0 and 1. We can make this the degree cosine of 30 degrees. And I believe instead of saying if the dot product of these two vectors are less than the threshold, I'm going to want to actually make that greater than. Okay, so now if I were to run the game, and if I were to smooth the vertices in the going merry, we should have the, for example, the sail being smoothed, and maybe the back of the body of the ship being smoothed. I don't know what the, like, terminology for different parts of ships are. I'm sure there's a name for it, and I just don't know what it is. But meanwhile, harder angles such as the corners of the railing should not be smoothed. So let's see, if I were to... Wow, this video has been a bit heavy on the brain farts. I don't know if anybody noticed that I changed this I plus equals 36 to I plus 36 times 3 without drawing attention to it. I started to write this code a different way, and then decided against it, and then, like, undid a bunch of changes, and then I forgot to undo this change. Let's try that again. So if I were to run the game, and if I were to try to smooth the normals on the going merry, like this, you can see that they do indeed smooth, and some of them smooth more than others. You can see that the back of the ship here, the normals here have been smoothed. You can see parts of the flags have been smoothed, but not all of them, because some of them are within the tolerance, some of them are not within the tolerance. You can see the sharp 90-degree angles on the like the corners of railings and stuff, and on the cabin have not been smoothed. You may want to play with the tolerance. You may want to make this like 45 instead. You may want to leave this up to your 3D modeling tools so that you don't have to try... Whoa. That is not okay. So that you don't have to try to do this programmatically. Again, this is something that you will more likely be needing to do if you are trying to do something such as generate terrain on the fly and you want the hills and the terrain to be smooth rather than faceted. In practice, you probably want to pass a threshold in as a parameter to this function, to this calculate smooth normals function. We can make that a parameter. We can pass that parameter into this function over here, and we can say this is going to be d cosine of, what did I say, like 30, I think was the original value. And oh, did I accidentally run this into debug mode? Who cares? This is now a parameter of the function, and the threshold is no longer hard coded. But that is for you to decide. I am going to close that. I'm going to close the debugger because I did not mean to open that. Windows Firewall, yeah. Every time GameMaker updates, it has to ask for permission to run the debugger through the firewall all over again. It's fun. Anyway, I'm going to commit these changes. We can call this implemented smooth normals. This should be the last that I talk about normals in 3D space until we get to the subject of normal mapping, which is probably going to be a little ways off from now because I want to do some other things in the meantime. Regardless, I hope you found this video useful. I try to post about 2 game dev videos a week. I like to focus on the weirder and more obscure things that you can do in GameMaker, so if you're interested in any of that, feel free to subscribe. Otherwise, I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places. You can see your name in the credits, hear yourself shouted out at the end, you can see a preview of my future plans, that kind of thing. Otherwise, if you want to see the code here, I'll look for the GitHub repository down in the video description. I guess this time around, I'll mention that I don't mind if anybody uses the code that I write in these videos in their own games or whatever, but especially in cases like this. This is not what one might call production ready. This has... I'll try and comment it a little bit better before I push it to GitHub and all that. But this code in particular is some that you may want to adapt to your own purposes before you try to just use it in your game, since it does make a number of assumptions about, for example, the way that your vertex buffers are created and what you'll be doing with them and that kind of thing. But regardless, I hope you all found this useful. The code is there if you want it, and I will see you all later. Special thanks to Edward Holt, Emily Koyo, Gunnar Clovis, Poshar, Sindra Larson, Squarecrow, Tusk, and Zenjamin for supporting these videos. If you want to see your name in the credits or hear yourself shouted out at the end like this, head on over to the Patreon page down in the video description to join the fun.